Okay, so what I'd like to do now is hand over to Doug from Magor. Hello, Doug. And we'll take a tour through telecollaboration and video conferencing. Thank you.
Thank you, Jonathan. And good afternoon. Thanks very much to Britannic and for Mitel for inviting me along. Let me gauge your pre-knowledge a little bit. How many here organisations are using video conferencing at the moment? Okay, quite a lot of you. How many here have seen Mitel's telecollaboration system before? Okay, not so many. All right. Okay, what I'm here to talk to you about is Magor TeleCollaboration. It's different from video conferencing. It includes video conferencing in it. And what we like to think that telecollaboration sort of carries on where video conferencing leaves off. Video conferencing has been around in a viable form for about 20 years, just over. And it's been designed to be able to facilitate a meeting at a distance without the need to travel. That's it, basically, in a nutshell. When it was first introduced, it was eye-wateringly expensive, and only the largest companies used it, and it was used at the upper echelons of business. And we all know that the people that work at the upper echelons of business don't actually do anything. So, present company accepted if I've chopped any toes. What those people do is the strategic meetings about what the organisation is going to do and perhaps who's going to do it. But they don't actually do a lot of work in terms of taking tasks forward. So being able just to see and hear each other was fine. And they kind of moved on to say, okay, I can show you a few slides. Great. But actually getting on and doing something, it's a bit formal, it's a bit sort of constrained, it's not an easy environment. What you end up doing is saying, great, that's a great idea, I've got a spreadsheet about that, I'll send it to you in an email next week and we'll talk about it in a couple of weeks. What telecollaboration does is it allows you to move tasks forward. It's more an ad hoc working tool rather than the more familiar use case, which is really having a meeting and seeing and hearing somebody. So it's more a kind of collaborative and immersive collaborative experience. Now, we should try and deal with some semantics. Telepresence is a term that you would have been aware of very recently. When video conferencing was young, telepresence was around. Everybody thinks it's a recent thing, but it's not. It's been around for 20 years at least. But what telepresence tried to do was to try to create an immersive room, so it felt like you were in the same room as the person you were talking to. So we're talking about multiple screens, multiple cameras, and even to the point where they used to paint the walls the same colour, and actually sometimes put the table up against the screen so you could see the far table, trying to get the brain to think I'm in the same room. Actually, it's a lot easier, that trick, than we thought it was, and there are some very important non-verbal clues that make that happen, and we understand how that works now, and you don't have to paint the rooms the same colour. What we've got here is a 3-screen, 2-camera telecollaboration system. It looks like telepresence. That was the old definition of telepresence. You know, it's an immersive, large-screen system. Maybe 6 or so people can be sat in front of it, and you've got multiple codecs calling multiple sites. This isn't a telepresence system, even though it looks like it. It can be that, but it's a lot more and it's a lot different. We can have a 2-screen version, you can have a single-screen version. You can have 3 cameras, 2 cameras, or 1 camera. We've got a desktop version as well for executive power using 24-inch screens. We're moving on to a new system, which we call the HD Personal, which is running inside an all-in-one PC. The key to our differentiation is manyfold, but first of all, let me ask, can anybody want to guess what a 3-screen, 3-camera system might cost? End user price, roughly? No? I mean, you've all had the cost of telepresence systems, you know, $500,000, £300,000, £250,000? £3,000. Okay. Less than 30. Going right down to personal systems that we will be bringing on the market shortly, which will be less than 6. And very powerful software running on a off-the-shelf, commercially available PC platform. This one's running on a Dell. High-end workstation, lots of CPU, lots of cores, lots of threads. Couldn't have done it 3 years ago before the Intel quad-core stuff came along. This is actually hex-core. So we are now porting that software into lots of different form factors. So really, it actually is the same software, runs right across the range. So it's very different in that sense. It's also different in its peer-to-peer. Those of you who have implemented video conferencing will be very familiar with the cost and implications of infrastructure. Well, you've already got a piece of infrastructure. You've got a beautiful Mitel switch. This is a SIP device. So it's got a 5340 here, sitting happily. I can dial from that. I can receive calls with it. The interface to the user consists of a telephone and one of these. Most of your users, I won't say all of them, but most of the users can handle a telephone or one of these. Where video conferencing has gone wrong in the past is they've handed the user a very complicated multifunctional remote control and expect them to get on with it. Or a touchscreen panel which is inhibiting for somebody that walks into a room. This is not inhibiting to most people. But if I want to make a call, I can do it on there, or I can do it on the on-screen UI. So what I'm going to do is I'm going to stop talking, and I'm going to make a call through to my colleague who's sitting over in my office, which is in Leicester Square in London, so not very far away. And then we're going to bring in some other callers. And because it's peer-to-peer, there's no infrastructure, there's no MCU, there's no gatekeeper, there's no scheduling software, there's none of all this stuff that costs loads of money in the infrastructure. And by the way, we're doing it over the internet, which is another bonus of the way we implemented the system. That doesn't mean we can't talk to your Polycoms, to your Tandbergs, to your life sizes, to your whatever you've got. We can do that as well. But when we talk to each other, we talk in SIP, and we talk in a form of encoding that allows us to work over non-managed networks, even to the point of transatlantic calls on the internet. So what does that mean? It means that if you're using MPLS, you can put it on the bottom level. You don't have to put it on the top level. The bandwidth you require is a lot less expensive down the bottom. If you've got an office that's on a small office that's maybe on the end of a thin pipe, you can't carry video on it, you can implement it over the internet and have reliable calls over the internet every time.
Could you get it through a 3G signal?
Yeah, yes, it depends where you are. Probably here we probably could. But it's a contended yes. Yeah. I'll come back to that because it very much works towards the mobile environment. It very much works towards the bring your own device discussion that Saul was referring to, which everybody's having to deal with. And our design is inclusive of all those trends plus virtualization. We have a story in that and a roadmap that's taken us in that direction as well. So. It's very much up to date in terms of the trends and the challenges that you're having to deal with today. So what I'm going to do is I'm going to call. I can do it two ways. Let me do it with the telephone. But all I can do is I just scroll down until I find Magor London and press a button. And he's not there. Hi Phil. Sorry.
Hello.
I'm going to move you over to the other screen because. The angle of that screen is a bit difficult. So this is Phil Sparrow. Phil's not more than about 5-6 miles away. Sitting in our office in London, and you can see immediately the quality of the image that we're managing to achieve over the internet. That's 1080p, 30 frames a second video. It's the highest quality video conferencing that you can get currently, and it comes out of the box like that. There's no additional cost for it. Those of you who have tried or looked at implementing 1080p 30 will know there's a significant premium to do that on our competitors' systems. But this is out of the box, 1080p 30. It's taken about 2 megabits over the internet. It's very, very flexible. We use an encoding a technique called SVC, which adjusts the amount of bandwidth it needs according to the congestion in the network. It's a very good network citizen. ABC, which is this way it's done normally, tends to grab a certain amount of bandwidth and hang on to it for dear life. And what happens is as the network gets congested, it starts to drop packets. When it sees packet drop, it starts to send forward error correction. So just at the time your network is getting congested, ABC is sending more data into it. So what SVC said is I'm backing off. I can see there's congestion in the network and I can back right off to less than 200 kilobits if I have to. Gradually, gracefully, dropping down the resolution, ultimately dropping down the frame rate if you have to. This is 30 frames, so it will stay there as long as it can. Always protecting the audio underneath, because the audio is the meaning of the meeting. Without that, you can't continue. So that is the last thing to go, and if that goes, you really do have a problem. It's asymmetrical, so it will run on an ADSL line, for example. You get a great picture down, they won't get such a great picture up, but the system deals with it. Again, treating each connection separately and adjusting the video according to what it sees available out there. So it's very flexible. So Phil and I can have a discussion. Phil wants to share something with me. Again, you know, some of the reasons that video conferencing hasn't been used in the past is because users find it really difficult or intimidating. With 1080p, something lovely happens. It means that Phil can stand up and draw something on the whiteboard, and I can see it. So on standard definition, you'd be lucky to see the whiteboard. But at 1080p, you can start to work as if you're in the same room. And so when we go through to our systems, you always see the whiteboard behind us. And that can be a flip chart, you know, you can bring it in and use it because you can see it. All right, you're a little bit distant from the screen, but if you were close to the screen, you'd see it clearly. So the users are not being asked to use any special technology. They're going to use what they use in a meeting anyway, and that's what we're trying to achieve. Why do we use cameras where they are? Well, one of the side effects of sticking a camera on top of the monitor or well below it is that you lose eye contact. And if you want to try and create this immersive feeling, I'm in the same room with you, I really need to have eye contact. So we discovered that if you put the camera where we put it and we aim it upwards slightly, you get that eye contact. So again, it's one of these non-verbal clues that makes you feel you're in the same meeting with somebody, rather than somebody staring at you up there and talking to you for 20 minutes, or down there, depending where the camera is. And you get that differential angle between the camera and the eyes. It gets beyond about 5 degrees and the brain loses the eye contact. It won't believe it has an eye contact. So that's why we have the camera there. And why do we need multiple cameras? Okay, well, what I'm going to do now is, if you use video conferencing, you know the scenario. You're talking to somebody, I'm talking to Phil, and we suddenly, you know, we have an ad hoc kind of discussion. It's not on the agenda, and we say, oh, I tell you what, I tell you the guy who knows the answer to that is Paul. Paul is in Ottawa. It's very early in the morning in Ottawa, but I know Paul is in because I have a presence engine, and the presence engine tells me when it's available. So Paul has the answer. Now, if you're in a standard video conference, what do? I need a bridge. Okay, let's close this call down. Let's call Paul later. Let's get him to come into a bridge call next Tuesday at 3 o'clock in the afternoon. We'll have to, we'll have to reserve the bridge resources, and we have to make sure the rooms are available, and blah 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 blah. And it doesn't happen, or it gets delayed. And we're talking about productivity here. So either because we don't use infrastructure in the way that standard video conferencing does, either Phil or I can call Paul, or anybody else, up to 10 other people in one site. Now again, it's an 11-way MCU call, if you like, you think of it that way, an 11-way multi-way call out the box as part of the cost of the system. I can tell you that a 12-port 1080p bridge, an MCU, will set you back around about minimum £70,000. Then there's plus on top of that. So, you know, total cost of ownership of this kind of system is already way below what you may expect. So Phil, would you give Paul a call, please?
Sure, yeah, he's in Ken's office right now. I'll just...
Oh, is he? Okay. So we're going to call Paul. Paul's in Canada. Paul's in the marketing department. And either Phil can call him or I can. And we'll just bring him into the call. I don't see him.
He hasn't answered yet.
That could be something to do with it, yeah. A lot of our systems are on auto answer, some of them aren't, and as well as the policy. So when Paul comes up, he will come up on that screen, or they might swap around the system, works it out. So it answers the question, why have we got multiple cameras? Because wherever there's a camera, we can put a far end video. There it is, okay. Hey Paul.
Hello, Doug.
How are you? It's very early in the morning out there, I know. Thank you very much for coming in and joining us.
Yeah, no problem. Early and minus 20 and beautiful.
I know what it's like. I was there last year, this time of year in October, it was minus 26. Painful, really painful. You guys know how to deal with that. You got any snow?
Yeah, we've got several feet.
Okay.
Interesting there, though.
Paul's at his desk. He's got the desktop version I was telling you about. So, to keep the eye contact stuff going, there's a camera where Paul is and there's a camera where Phil is. If I wanted regularly to bring in a third side, I could do that, but I need to put a camera there because of the eye contact issue. Now look what happens. If I said to Phil, look at Paul, he looks over there because the system has put Paul on his left, even though Paul is on our right. It's mirrored it. So when I say to Paul, look at Phil,
He's over here.
so these are the non-verbal clues that make immersive teleconferencing work. Not painting the walls the same colour. This is very important with gaze direction management, as we call it. And so you end up with a big global table, sort of virtual table. So we can do this, and we can keep on bringing in sites. Obviously, we'll run out of screens eventually, and we put them side by side or whatever. If I was on a single screen system, for example, I'm going to bring Paul over and emulate what will happen on a single screen system. Now you've seen this before, and if there was 4 sites, we put it in a quad, and if there was 6, and so on. Interestingly, because it's 16 by 9, we're wasting a huge amount of space, and there's only one guy at each end. So I've got a little trick we do, which we call portrait. Now this is cool because once I do that, these are fixed cameras, but I can move them around now because I'm moving it around in memory. So we don't have any nasty pan, tilt, zoom stuff, and how do you control it and all that. Because pan, tilt, zoom cameras were introduced to overcome the shortcomings of standard definition. Because you couldn't see anybody, you know? So you had to zoom in. 1080p30, you see everybody. Why zoom? Get rid of the pan, tilt, zoom as unnecessary complication. But once we are zoomed in, we can move around, and once we have this portrait. So now I've got 2 guys. One is in London, the other one is in Ottawa. They're 3,500 miles apart, and they're on the same screen, and they're in the same meeting. And it's just like that. No bridges, no complication, just bring them in. Now, if these guys say, okay, they start talking, and I say, well, okay, you guys understand this, I'm not involved in this anymore, bye-bye. I can drop the call, they will still be in it. Okay, so this is another seemingly obvious thing to be able to do, but it's never been something you could do in video conferencing before, because it's always been approached in the wrong way with the wrong architecture. So now we're in the same meeting, and I'm going to put Paul back over there. I started this a few minutes ago saying, you know, we start off, we carry on where the old stuff stops. So this is really old stuff. We do it really well, but it's old stuff. Some benefits in it already, but now we want to talk about doing things, tasks. No good as so. Phil, we start a conversation, and Phil says, I got a spreadsheet on that. Phil's going to bring up the spreadsheet. So he's not going to come to the meeting room with his laptop and plug it into a VGA plug. No, that's yesterday's technology. Phil just brings it up from the machine wherever it is on the network. Okay? Let me show you the user interface a little bit. Down here it says available resources. Okay, you won't see it from the back, but basically these are computers. Now these computers can be Windows machines, like this one. They can be Apple Macs. They can be Unix, they can be Solaris, it doesn't matter. We can do this trick with anyone. Basically we're sharing the desktop from any PC on your network. And it can be a virtual PC, it doesn't have to be a physical PC. It can be out on the internet. Just as long as you can see and ping the IP address, you can do this. And there's no additional software that you need to put on the PCs to make this happen, because we use the inherent capabilities of the operating systems to do this. In Windows, if you want the details, we use RDP, and Apple Mac ships with VNC. Very secure, same rules apply in terms of opening the session up and so on. But It means you have instantaneous access to any PC that you can see on the network. And what we do is we create little icons on the side to machines we use regularly. I've got my laptop running here. It's plugged into the back of the phone on the network that's running the system, and I can share my laptop back in. So we can now talk about this spreadsheet, and we can get on with the task. Right? Remember, this is about productivity. It's not about saving somebody a journey. Of course, that happens as well. But it's in a situation where you wouldn't be journeying anyway. You wouldn't be going. I mean, I'm not going to go 3,500 miles to Canada to talk about a spreadsheet. So, this is about increasing productivity now. And yeah, you're going to get travel savings, but, everybody knows what they are, and whether you achieve them or not is a moot point, because, your business is like, did you stop sending letters when you got a fax machine, those kind of things. So now we need to work on it. So I'm just going to say, look, I could say to Phil, okay, Phil, look, change the northern region to 100 million. Or I could say, hang on a minute, Phil, can you give me control?
Sure. There you go, you have control.
Okay, so now, what happens now is I am controlling the application that's running on Phil's PC, and I can put my own numbers in, and we can work interactively together. So it's more than just showing a set of slides. It's about, let's work on this application. It could be any piece of software that's running on that PC, we can share. And I can operate it and run it. It's like a long KVM switch, basically. My keyboard and mouse and my monitor are now working that application. So we can work on that for half an hour. Paul, do you want to add something in? I think, why don't you give us a number for the Western region? You're about as west as you get in my world. Okay, so Paul can do it as well. So maybe you can get a bit of mouse wars here. You have to be a bit disciplined, but So Paul's sitting in his cubicle. I do this regularly because Paul and I work together quite regularly, as regularly as I work with Phil, who's in the same office. But I'll go and hang out at Paul's cubicle. The system normally auto answers, and I'll just sit there until he gets it. As if I can get on with my work. Well, I've got the screen up, so when Paul comes in, it's up. I need to talk to you about something. It's kind of that water cooler discussion thing that the Americans always go on about. When you exchange information. I've talked to customers where they've got their business on 2 separate floors of the same building and they don't talk together. If we go about 3,500 miles, we talk as if we're in the same building, at the same level, in the same, what do you call those, pens, right? Cubicle pens, or something like that. Yeah. So when you've got an open plan office of cubicles, it's a bit like being in the office, and it works really well. So what happens if we want to bring another site in? We can do that. Hey, Paul, why don't you bring somebody in this time? I don't hear you. Are you muted?
I am muted.
Okay.
Actually,
yeah.
What I'm going to do, I'll show another environment. I'm gonna make a call and walk over to a different room just to show another environment. So I'll be right back.
All right. When was I supposed to finish? Okay, all right, I've got about a quarter now. So, if you're in front of a Magor system, and I've got a dual screen system in front of my desk, in my office, it's my personal system. Remember, what does it cost to put a large screen into an office now? These are 46-inch screens, I think. You can buy them for like £500–600. The fact that you've got 3 great big screens might seem extravagant, or 2 screens might seem extravagant as a personal system in your office. But you know what? If it's running on a PC as a piece of software, the only difference is the cost of the screen. So, don't know where Paul's gone. I'm going to bring these down here. You see this? These little my views. These help you keep track of who's on the call. So, I can put Phil up there on his own, or I can put him next to his spreadsheet, depending on. This is another thing you don't get with MCU. When you use an MCU, the MCU sends you what the MCU wants to send you. Because we're doing peer-to-peer, each of the streams, whether they be video streams or data streams, are coming as independent streams. So you as an end user can choose what you're doing. So supposing you're in a 3-way like this, and Phil's given a presentation to Paul, and Phil and I know this presentation, we wrote it ourselves. I'm not interested in what Phil's doing. I'm interested in Paul's reaction. So I'm going to go and look at Paul. Whereas somebody else might be looking at Phil and the collaboration, depending how many screens you've got, whether you put them all up at the same time. So the difference between one screen and 3 screens is really just real estate to put this stuff on. Because you might have a couple of, we can put multiple collaboration screens up. They can come from different sites and so on. So Paul is now in the VP of Sales and Marketing's office. So he's just moved up the corridor. So we now have 3 sites running. If I wanted to bring back Paul's original desk, I could do that. Or if I just press the control button, I can put them side by side again. So you've got all this flexibility of what you're looking at. And I think you've never been in a presentation and a video conference where somebody's showing a slide, and 20 minutes ago they stopped talking about the slide. They stood, and they're down a little picture, and you're still looking at this slide. Yeah, you can control what's said or what you say, so that's a big difference. So then, what happens if you're not in a Magor? So not everybody's going to be in front of a Magor system. Unfortunate but true. The world is going mobile. They may not even have a PC. They may not even have an office. They may only have one of these things. iPhone, iPad, if you're lucky. If you're not, BlackBerry Torch. The first BlackBerry Torch. Bounces off of Windows, I know. Android, whatever. So in this situation, you're talking to 3 guys, one guy's over in Canada. We need to talk to Fred. Where's Fred? He's working at home today. Okay. Does he have a Magor system? No, unfortunately he doesn't. Okay. Does he have a PC? No, he's only got one of those iPad things. Okay, has he got Wi-Fi? Yeah, great. Okay. Phil, can you bring up the page I was talking that we did on the spreadsheet? Mm-hmm. Please. So I'm just going to bring this up. Any of you in the room at the moment who have a smartphone or an iPhone or an iPad, you might want to put that into the browser. Now that is the URL of the endpoint that Phil's setting up. Okay, all the endpoints have a web server in them, and each of the endpoints are serving the collaboration screens and the videos out to the internet or to the network. So Fred, who we need to talk to, has to come in by phone. Okay, phone's in, joins the conference by phone. Everybody can hear him, and he can hear everybody. But it's not much good if he can't see what we're talking about. So he will put that address into his laptop, desktop, iPad, iPhone, whatever. Any browser will do this, and again with no plugins, no additional software, nothing else to worry about on the build. Nothing else to worry about whether so-and-so's BYOD does this or not. This is done using HTML5 and it's supported in all the new browsers. So when you get to the page, now you see you'll get this green login page, and at the top it asks you for name, just anything that represents you, doesn't matter. And then underneath it's got an access code. And when we make a call with a Magor system, it automatically generates a 4-digit random PIN. So Fred's on the phone saying, someone give me the PIN, I can't see anything. Okay, right. Anybody can go up here who's in the call, click on there. It says down the bottom, or along here, the web collab access code is 8474. Fred put 8474 in the access code. Bonk, he's logged in. Okay. Now, you can actually change that. If I wanted to change it to a pre-arranged PIN, so if I sent the URL out to somebody in an email, said, look, join us on this, and it's going to be 1234, I can now go and change it to 1234 so that they can log in on a previously agreed PIN. Anybody in? What have we got so far? It does, yes, somebody has joined me. Mark has joined.
That's the same.
All right, okay, good. So now at the top right hand corner of the screen, and I'll just get to, why can't I see you? Okay. I'm just going to, everybody finished with that now, I'm going to get rid of it. Okay. I can't find your video. Why can't I find your video? Phil?
Oh, sorry.
Yeah, thank you. Engineers. Right, so Phil, if you want to just hold up your iPad there and show it to everybody. So now Phil is logged in and he's now looking at the collaboration screens that we're sharing. So at the top right hand corner there's a drop down box. I'm not quite sure what it says. Sometimes it says shares. There's a little drop down button. If you drop that down and select something like Windows Vista, you'll find the spreadsheet. There's also sending still images from each site. So in that drop down list you get all the collaboration, plus you get still images which are updated every few seconds from each of the sites, so you can remind yourself who's in each room. Because you've ever been on an audio call with 10 people talking, half of them are maybe from the States, you've just got no clue who's talking. You can now go and look at the rooms. It sends little JPEGs every couple of seconds. The reason it doesn't send streaming information is because you remember you're on the phone and you're getting instantaneous voice and they're getting instantaneous voice from you. If you stream it, it takes about 20 to 30 seconds. It's going to be way out into lip sync. So at the moment we just send stills. So now Fred, who's at home, remember, is sitting on his iPad and he's now connected. He's on the phone to us. In fact, you can do it with just a single device. So if I called in to there's a voice called on here and then brought up my browser on here, even something just as simple and small as this, I can do this. And what happens is, Phil, if you can put that a bit closer, you can expand using the pinch. Can you expand? We send this data in the original resolution from the computer we're connected to. So even if you've got a little window like that, you can do that and you can zoom straight into all the details. You can move around. Rather than what happens with PBS is something you zoom into it and nothing happens. You just get a bigger version of what you can't read. So you've got all the... So now we're inclusive. Anybody out there with in a hotel, on a... Oh, God forbid, on a plane now, because we're getting internet and voice on the plane, can join in for a few minutes. We may only need Fred for a couple of minutes and say, okay, what are we going to do in this situation? He's the expert in this situation. Bang. Get the answer, then go. Productivity. Getting things done now. When you need to, get on with your life, get on with the next task. And because this is more kind of personal ad hoc system, which I hope you're getting the point about, and because it's so far less expensive than traditional ways of doing this, that more people can use it, and when more people use it, the productivity goes up, the return on investment of your room-based systems goes up because there's more people to call, and the people that are using those room-based systems are getting more done in the time. And we're all under pressure to get more done, less people, less time. So this works into the pressures that we're all feeling. Finally, what you're seeing now is basically the capability of the current software. We're about to release our next major revision, 5.0. 5.0 brings a couple of benefits. First of all, if you had Polycoms or Tambergs and so on, and we called you from this, you would see the endpoint that you're calling, but you wouldn't see everybody else. And the endpoint that called the Polycom would only see the Polycom, but nobody else in the Magor multi-way would see it. We're fixing that in 5 with something we call media relay. And that means that if you call out to a non-Magor system from any of the endpoints, that system will relay it to the others. This has some interesting implications about providing MCU facilities for non-Magor systems. But that's a deeper discussion. Anybody wants to have it with me, I'm going to be here during lunchtime. But what we're really excited about is, you see what we're trying to do. No additional software to be able to share a computer. Nothing to change the build. No plugins, no clients. No additional software to do HD share, which is this function that we're working from a PC and sharing the data. That's all done with HTML5 on a standard browser. So that's our philosophy. We don't really want to be a designer of desktop client software. That's not what we do. So when we thought about how do we bring people like Fred in as a video participant, remember he's at home and he's only got an iPad. We said, what's the most ubiquitous, that's not a contradiction in terms, what is the most common video client in the world? Anybody? The most common video client in the world. The ones most likely to be on your PCs already. Skype. Skype tells us they've got 100 million business video users. And forget Cisco, forget Polycom, forget all these guys. 100 million users, business users of video. So we said, well, okay, why fight it? What we do, so on the next release, we're introducing a native Skype codec. So in a situation like this, any of us can call a Skype endpoint. So that was Fred in our example. We call Fred. Fred's got Skype running on his iPad 2, or better, and he's got cameras built into it. And so Fred can join us as a live video participant, still sharing the data as he was doing in the browser, but now we can see him here. And you can do that in even with something like this. Anything that would run Skype would do this. Now we think that's quite interesting. If people are going to say hello, it's me. Fine. I don't know what the value of that is, especially if you're on 3G. Pictures quality is not going to be great. Remember, we use 2 megabits. 4G is supposed to deliver, anybody, 150 megabits? I mean, we're going to get some pretty interesting pictures off of 4G. The 3G is still challenged. We think it's much more interesting if you did that. Now, when you do that, you say, what am I going to do about this? So you've got your subject experts are sitting back at the ranch or in several ranches. You've got an incident going on out in the field. You're pointing your camera down a hole in the road which is gushing 30 million gallons of water every 2 minutes, saying, what do I do about this? And you can bring your experts straight into the field to handle incidents, production difficulties, and so on. You can, as much as your imagination will take you. So we think that's really important to be able to send good video from the field, not just from seeing somebody, but for seeing other things that are going on. I'm going to stop there and keep us within time. Paul, thanks ever so much for joining us. Phil, thank you.
Thank you. Thank you.
I'll tell you what, stay on, because if there are any questions, I probably won't be able to answer them. So thank you. Are there any questions? All right. Beaten into submission.
What's the practicalities then? If they're all peer level communications, you got a 10-way communication going on. You're using that's a 20 meg at an endpoint.
Thank you. Yeah, it would be. You're absolutely right. And I should have mentioned it before. But you see what we're doing with Paul. We've got his 2 screens side by side. On Phil, we've got full screen. So the endpoints talk to each other. And the endpoint is saying to Phil's endpoint, I've got your full screen, send me 1080p. So they send in 2 meg to us. Okay. Paul's endpoint, well, both of the endpoints, are being told by this endpoint, I've only got you side by side. In fact, if I can tell you what they're at.
As you show the bit rate.
Yeah. That's only running 1 meg, so it's sharing 2 meg between the 2 sides, because it's saying, look, I've only got you running at 540p. So why send me 1080p?
What about that? Nothing's moving in that.
Yeah, it's going to be like slightly less because there's no motion. You're right. Yeah, but it kind of load manages. So if you were talking to 4 sites and you had the 1, 2, 3, 4, then each one would be sending you 540p. Combine it together, it's not as much as 1080p as in a single screen. So in the Magor world, the actual amount of bandwidth you need is down to the number of screens you have, rather than solely down to the number of endpoints you're talking to. But even if you have the worst case analysis in that, which is basically, I'm the chairman and I'm sending out to 10 other sites a full image. Okay. Well, the chairman's going to have a bit of bandwidth available to him, one imagines, to do that. But even if he hasn't, the systems will load balance and they'll send as much as they can within the capacity of the circuit that they've got. And that will be adjusting on a second by second basis, depending on the congestion of the network. So it's quite flexible. Anybody else? Yeah.
Can they see you?
Can
they see you?
Well, as long as I'm in camera, yeah. That camera can see me, that one probably can't. It's designed so that you sit around. I mean, this is not the normal furniture we use. I mean, you can see Phil's just got a standard table, Paul's got a standard table. And you've got, in shot, you'll get about up to 6 people, depending on the distance from the camera and the lens we fit. And if you want more people than that, you just put another row of chairs behind, rather than have a sort of, you know, the worst kind of room for video conferencing is a boardroom. 24 chairs going down a long, thin room. Best size of room, shape of room for video conferencing is square with no windows. Of course, architects don't design rooms like that, but we're working on it. Thank you very much. Thanks for your attention.
No, sorry, one final question.
What about external connectivity to third parties who've got Tandberg's polygons over ISDN and standard IP?
Yeah, we interoperate with all the major codecs out there using standard H323 or SIP. Interoperability is something that we take very seriously. It's not a destination, it's a journey. Like everybody, we have to keep testing with the new software revisions of our competitors. They throw all the engineers in a room every couple of times a year, and they all go and try things out, and nobody says about what did or didn't work, and they will go back and change the software so that we maintain interoperability between us.
In terms of this is a peer level system, so I've got a customer who's going to dial in to me, and I might have two different. How do I facilitate that? It's not coming to a bridge into a central point, but I've got to make all of these things connectable.
Well, remember,
this is like ISDN. I'm not going to have necessarily ISDN to the desktop of the.
No. This is a SIP device, primarily. So it SIP trunks to your IPPBX. So it forms part of your 4-digit dialing scheme. So you'll have a domain, and you'll have a 4-digit number and an @ symbol as a SIP address, and you give that to the outside world. And as long as you allow calls in across your firewalls and so on, we've got a session border controller which facilitates calls across NAT and firewalls. So, when I call Paul, I'll call him at his 4-digit extension at ottawa.magor.com. The address where Phil is 6854 at london.magor. So that's how it works. I mean, we give those out to anybody wants to call us.
So that's native IP and SIP, but not what about ISDN then?
If you're doing ISDN, then you would have to have one of your systems either connected up on ISDN. Magor doesn't do ISDN because it's going away. But if you have ISDN-based systems, we can talk to those. Or you use a third-party service provider where you talk a SIP to them and get them to make the ISDN call or to receive the ISDN call and patch it in.
Well, can you talk through, for instance, like Codian ISDN gateways? Could you use that as a bridge?
Not directly. No. You could do it through a Codian bridge. They get the Codian to call us, and the Codian to call the ISDN one, and then bridge it across the Codian bridge, because the Codian bridge will transcode. Well, it will change. It'll deal with both
but as well,
communication.
So an ISDN natively is obsolescent.
We think it's going away. We wish it would go away faster. Of course, there's still a lot out there, but the way we tend to deal with it is with a third party. ISDN dialing is problematic anyway, if any of you have been trying to do it. If you're doing it on an ad hoc basis, it's even more problematic. So it's always well to get a third party involved anyway, who know the telecoms issues, and can actually check the system works and answers, and you know what protocols you're using and so on. It's quite complicated. This, of course, is just IP to IP, and it's a piece of cake. But yeah, ISDN can be problematic, so we generally recommend that you use a third party resource if you're going to do a lot of it.